For most of history, we believe that human technology evolved slowly. That ancient people used simple tools, learned step by step. And only in the modern age did we begin to understand complex engineering and physics. But every so often, we find something that doesn't fit that idea at all. Buried in ruins, hidden in manuscripts, or sitting quietly in museum collections. There are devices so advanced, they seem completely out of place. Some of them track the motion of the stars with incredible accuracy. Others use energy in ways we still don't fully understand. And a few are so precise. Modern engineers admit they would struggle to recreate them even today. These discoveries raise a difficult question. How did ancient civilizations develop such advanced technologies? Without the tools, theories, or scientific understanding we rely on now. Were these people simply far more skilled than we assume? Did they inherit knowledge from an earlier age? Or did entire branches of science rise and fall long before our history books begin? In this documentary, we're going to explore 12 ancient technologies that challenge the limits of what we think ancient engineers were capable of. Machines that behave like early computers. Inventions that mimic modern physics. And devices that push against everything we thought we knew about human innovation. By the end, you might start to wonder whether the ancient world was far more advanced than our modern timeline allows. Our journey begins with a device that continues to confuse even the most experienced engineers, the Antikythera mechanism. Discovered in a shipwreck off the coast of Greece, this ancient machine wasn't made of stone or clay, but of precision-cut bronze gears, some so small and complex that modern replicas require specialized tools to recreate. What makes it extraordinary is not just its age, but its purpose. This device predicted eclipses, tracked lunar cycles, and even mapped the positions of the planets with incredible mathematical accuracy. It functioned like a mechanical computer more than 2,000 years before the first digital one was ever imagined. And even today, engineers debate how ancient craftsmen were able to design such complex gearing with tools that shouldn't have allowed it. It's a reminder that knowledge can appear, and disappear, without leaving a clear path behind. Our second technology takes us far from the Mediterranean and deep into ancient Mesopotamia, where a strange artifact was discovered inside a simple clay jar. At first glance, it seemed like an ordinary container. But inside was a copper cylinder, an iron rod, and traces of an acidic liquid. When recreated in the modern era, this object produced a small but measurable electric charge, functioning almost exactly like a primitive battery. This, Baghdad battery, as it's known today, raises difficult questions. Why did ancient people create a device capable of generating electricity? And what exactly were they using it for? Some theories suggest electroplating metals. Others propose religious or medical purposes. Whatever the truth may be, the fact that such a device existed at all challenges our assumptions about when humans first understood electrical energy. Our third technology brings us even deeper into the past, to the world of ancient India, where texts describe flying machines known as vimanas. These weren't simple myths or poetic metaphors. The descriptions are surprisingly technical, detailing shapes, materials, and propulsion systems that sound eerily mechanical. Some passages even reference engines powered by rotating mercury, producing lift through mechanisms that modern engineers admit would be extremely difficult to build even today. Of course, historians debate how literal these descriptions were meant to be. But the level of detail found in these writings is unusual. They suggest either a deep symbolic understanding of machinery, or the memory of technologies far older and more advanced than we assume existed at the time. Either way, the idea that ancient civilizations may have explored flight in ways modern science still can't fully explain remains one of the most intriguing mysteries of all. Our fourth technology brings us to one of the most astonishing feats of ancient engineering, one that appears almost impossible, even by modern standards. Deep in the ruins of ancient Egypt, archaeologists discovered enormous stone blocks cut with a level of smoothness and precision that stunned engineers. These blocks were not just carved, many show surfaces that resemble the effect of modern machine tools, as if the stone had been shaped with drills operating at incredibly high speeds. Some of the cuts are so perfectly straight, and some corners so exact, that engineers today struggle to explain how they were made using only copper tools and manual labor. Even more mysterious are the perfectly round drill holes found in solid granite, a stone so hard that even modern diamond-coated tools struggle against it. The spiral markings inside these holes suggest a kind of rotary power tool, one capable of cutting through granite far more efficiently than anything we should expect from the ancient world. Were the Egyptians using a kind of lost mechanical technology? Or did they simply develop techniques so advanced that modern researchers still haven't figured them out? Whatever the case, these marks remain some of the strongest physical evidence that ancient civilizations possessed engineering knowledge far beyond our current understanding of their abilities. Our fifth technology takes us to ancient China, where an extraordinary mechanical invention once existed, a device known as the south-pointing chariot. At first glance, it looked like a simple wooden vehicle, nothing more than a cart on wheels. But hidden inside was a system of gears designed to do something remarkable: keep a pointer aimed in the same direction, no matter how the chariot turned. This mechanism functioned like a non-magnetic compass, long before the magnetic compass was invented. It relied purely on mechanical engineering, using differential gears to maintain orientation. And here's the part that continues to puzzle historians: differential gears are not supposed to exist in recorded history until the 19th century. Yet this ancient device, built more than 1,000 years earlier, performed the same function using principles that weren't formally documented until modern mechanical engineering emerged. Recreating a south-pointing chariot today requires precise ratios and extremely accurate gear teeth, and even with modern tools, it's challenging. How ancient craftsmen achieved this with wooden gears and hand tools is still a mystery. Some scholars suggest the design was passed down from an even earlier civilization. Others believe the exact mechanics were lost over centuries of war, fire, and cultural change. Either way, the south-pointing chariot stands as one of the clearest examples of an ancient invention that seems to break the timeline of technological development. Our sixth technology brings us into the world of ancient metallurgy, specifically, a metal so advanced that modern science required microscopes to understand it. In the Middle East, archaeologists discovered swords made from a legendary alloy known as Damascus steel. These blades were prized not only for their sharpness and durability but for their ability to bend without breaking, a property that baffled blacksmiths for centuries. What makes Damascus steel so extraordinary is not the metal itself, but the microscopic structures within it. Under high magnification, researchers found patterns called carbon nanotubes, structures discovered in modern times and associated with advanced materials science. The idea that a medieval forging technique produced something resembling nanotechnology is astonishing. No written record explains the full process, and even today, metallurgists struggle to recreate the original method. Many modern attempts have produced metal that looks similar, but behaves differently, lacking the strength, flexibility, or distinctive pattern of true Damascus steel. Some believe the secret recipe was lost because it required specific ores that no longer exist. Others think it was a carefully guarded trade secret that vanished as workshops closed or were destroyed. But the mystery remains: how did blacksmiths, working with furnaces and tools far simpler than ours, manage to produce a material that behaves like something from a modern laboratory? It suggests that ancient metallurgy may have reached a level of sophistication far beyond what traditional history acknowledges, and that entire branches of scientific knowledge may have risen and fallen without leaving clear records behind. These three technologies, the precision stone cutting of ancient Egypt, the mechanical genius of the south-pointing chariot, and the unparalleled metallurgy of Damascus steel, are reminders that human innovation did not always follow the linear path we imagine. They suggest that ancient civilizations were capable of breakthroughs that challenge our assumptions about what was possible in the distant past. And when examined closely, each one pushes us to rethink not just how these societies lived, but how they understood the world around them. As we continue through the next set of ancient technologies, the picture becomes even more surprising. What if these weren't isolated achievements? What if they were part of a larger pattern, a pattern of advanced knowledge emerging in different cultures, in different eras, all hinting at a deeper understanding of physics and engineering than we give our ancestors credit for. The next technologies on our list push this question even further, and bring us closer to one of the most profound mysteries hidden in human history. Our seventh ancient technology takes us into the world of hydraulic engineering, where one invention stands out as a masterpiece far ahead of its time. In ancient Greece, engineers built a device known as Heron's automatic temple doors. To a visitor, it appeared to be nothing short of magic. A priest would light a fire on a small altar, and moments later, the massive temple doors, crafted from heavy wood and bronze, would open by themselves. There were no visible ropes or pulleys, no servants hiding behind the walls. Yet the mechanism operated flawlessly, giving the illusion that the temple itself was alive. What made this invention so remarkable was the system hidden beneath the floor. When the fire heated the air inside a sealed container, the pressure increased and forced water through a siphon into a counterweight. As the counterweight descended, the doors opened with smooth, controlled motion. When the fire went out and the pressure dropped, the water returned to its original position, allowing the doors to close again. This was a fully automated mechanical system using principles of pneumatics and hydraulics that would not be formally studied again for more than 1,000 years. It demonstrated an understanding of pressure, displacement, and mechanical timing that feels almost modern in its execution. Even today, recreating this device requires careful measurement and precise construction. The idea that an ancient inventor could build such a seamless automatic system raises an important question. How many other mechanical innovations from this era were lost before they could be documented? Our eighth technology takes us to the ancient Roman Empire, where an extraordinary concrete was created, one that modern engineers still struggle to match. Roman concrete, used in structures like the Pantheon and aqueducts across Europe, has survived earthquakes, storms, erosion, and the passage of 2,000 years. The Pantheon's dome, in particular, remains the largest unreinforced concrete dome in the world. Modern engineers can reproduce the shape, but not the longevity. Our concrete, made with modern cement, begins to crack within decades. Some structures last a century if properly maintained. But Roman concrete appears to get stronger with age. Recent studies suggest that volcanic ash from the Bay of Naples reacted with seawater in a way that allowed the material to heal itself. Cracks would form, but over time, mineral-rich water seeped in and triggered chemical reactions that filled the gaps, essentially making the concrete self-repairing. This is a property modern materials scientists are actively trying to recreate using advanced chemistry and nanotechnology. And yet the Romans achieved it with simple tools, traditional kilns, and local materials. The recipe has been partially decoded, but the exact mixture, firing temperature, and curing methods remain uncertain. Some researchers believe the process was a closely guarded trade secret passed down through master builders. Others argue that crucial details were simply lost as the empire fell and construction practices changed. Whatever the truth may be, this ancient building material defies expectations and reveals an understanding of chemistry and structural engineering that still challenges our modern assumptions. Our ninth technology returns us to the ancient Mediterranean world, where automata, mechanical figures that moved on their own, captivated audiences centuries before electricity or robotics existed. One of the most astonishing of these was an ancient Greek automaton theater. This device allowed miniature actors carved from wood and metal to move across a small stage, perform scripted sequences, and interact with one another using gears, weighted cords, and carefully timed mechanisms. Some automata could pour wine, play instruments, or move their arms and heads with surprising fluidity. Others were designed to mimic animals or mythical creatures, creating illusions that must have felt alive to an ancient audience. The heart of these machines was an arrangement of cams, axles, and rotating drums engraved with patterns that controlled motion. By adjusting these patterns, an operator could change the timing, direction, or complexity of the movements. This system is the ancestor of modern programming, long before digital code or even punch cards existed. Recreating these automata today requires advanced craftsmanship, mathematical precision, and careful synchronization of multiple moving parts. The fact that ancient engineers were able to design and build such intricate systems suggests a level of mechanical sophistication that rivals the early stages of the Industrial Revolution. And yet these devices were created almost 2,000 years before steam engines, factory machines, or modern robotics were developed. What's even more fascinating is that many ancient texts reference even more complex automata, machines capable of mimicking human expressions or responding to environmental changes. Some were used in temples to create the illusion of divine presence, others served as entertainment in royal courts. Most of these devices have not survived, leaving only descriptions and fragments behind. But even the surviving examples demonstrate a deep understanding of mechanical physics, motion control, and material behavior. They remind us that our ancestors did not simply imagine mechanical life, they built it with the tools they had, using principles we still study today. These three technologies, automated temple doors, self-healing Roman concrete, and ancient mechanical automata, push the boundaries of what we typically consider possible in the ancient world. They show us that innovation is not confined to a straight timeline. Knowledge can appear, vanish, and reappear in unexpected ways. And history, as we know it, may reflect only a small fraction of what humanity once understood. Our 10th ancient technology leads us to one of the most mysterious artifacts ever discovered, the Lycurgus cup. At first glance, it appears to be a beautifully crafted Roman chalice, decorated with intricate scenes carved into the glass. But when light passes through it, something extraordinary happens. The cup changes color, shifting from a soft green to a deep red depending on the angle and intensity of the light. For many years, scholars couldn't explain why this object behaved like a modern optical device. But eventually, researchers discovered that the glass contains particles of gold and silver hammered down to sizes measured in nanometers. These particles create a phenomenon called plasmon resonance, a principle used today in advanced imaging technologies and sensors. The idea that ancient Roman craftsmen were intentionally manipulating nanoparticles is almost impossible to believe. Yet the evidence is right there in the cup. Was this an isolated discovery? Or did ancient artisans understand far more about optics and material science than we ever imagined? The Lycurgus cup remains one of the most compelling examples of ancient technology that operates on principles we only formally identified in modern physics. Our 11th technology brings us into the realm of sound and vibration, fields that have fascinated both modern scientists and ancient cultures. Across multiple civilizations, from Greece to India to the Middle East, we find references to structures and devices that harness the power of acoustic resonance. One of the most intriguing examples comes from ancient Egyptian sites, where certain chambers appear to amplify and manipulate sound in ways that feel almost engineered. Some chambers produce standing waves that vibrate through the air and stone, others seem to enhance particular frequencies while absorbing others. There are reports from early archaeologists describing rooms where a whisper can travel across great distances, while normal speech becomes strangely muted. Modern researchers have noticed that the dimensions of these chambers match mathematical ratios associated with harmonics and resonance. But here's the part that breaks expectations. Acoustic engineers today still debate how these effects were created, and whether they were intentional or simply a byproduct of architectural style. If intentional, these chambers would represent a deliberate understanding of acoustic physics thousands of years before modern science developed the field. If accidental, the coincidence is astonishing enough to raise questions about whether ancient builders possessed knowledge that we have not fully recognized. Either way, these chambers hint at an ancient awareness of how sound behaves, a knowledge that could have been used in rituals, ceremonies, healing practices, or even proto-scientific experiments. Our 12th and final technology brings us face to face with one of the strangest mysteries of the ancient world, the vitrified forts of Scotland and parts of Europe. These ancient stone structures show signs of having been exposed to temperatures so extreme that the rocks partially melted and fused together, much like glass. To achieve this effect intentionally would require heat far beyond what simple campfires or torches could produce. Even modern experiments using wood, charcoal, and portable furnaces have failed to reproduce the same level of vitrification found in these ancient sites. Theories range from accidental wildfires to deliberate military strategies, but none fully explain how such intense heat was generated over such large areas. Some researchers speculate that ancient people may have used a form of blast furnace technology unknown to us today. Others believe the vitrification was unintentional, caused by some catastrophic event that has since disappeared from the historical record. But the truth remains elusive. These structures challenge our assumptions about what ancient people were capable of achieving with heat, energy, and material manipulation. And they remind us that there are still aspects of ancient science that we have yet to understand. Taken together, these 12 technologies form a picture that is difficult to ignore. Each one, on its own, is fascinating. But when viewed alongside the others, they suggest something far more profound. They reveal that ancient civilizations were not simply primitive societies progressing slowly toward the future. They were cultures capable of significant scientific insight, mechanical skill, and innovative thinking, skills that, in some cases, rival or surpass our modern understanding. This doesn't mean they had supernatural powers, or that they possessed modern machines hidden in forgotten temples. It simply suggests that human intelligence has always been far more remarkable than we often acknowledge. People of the past were experimenting, discovering, and refining ideas in ways that challenge the timeline we've built for ourselves. And much of what they knew may have vanished with them. As we continue to study ancient artifacts and uncover new pieces of history, we may find that the past holds more surprises than the future. And perhaps, somewhere buried in ruins or sealed inside forgotten texts, there are still technologies waiting to be rediscovered, technologies that could once again reshape our understanding of the world. The story of ancient innovation isn't finished. It's only just beginning. As we close this journey through some of the most extraordinary technologies of the ancient world, it's worth taking a moment to step back and look at what these discoveries truly mean. We often assume that progress moves in one direction. Forward. Steady. Predictable. We tell ourselves that each generation is a little more advanced than the one before it. And that the tools we build today are the pinnacle of human achievement. But history, when examined closely, tells a very different story. It shows us civilizations capable of remarkable insight and technical mastery. Built not with modern machinery, but with patience, observation, and an understanding of natural principles that we sometimes overlook. It reveals moments where knowledge surged ahead, and moments where that knowledge faded, disappearing into the ruins of forgotten cities, and the silence of lost traditions. It reminds us that progress is not a straight line, but a wave, rising, falling, reshaping itself over centuries. And it challenges us to reconsider what we think we know about our ancestors. Were they simply experimenting with ideas that we later rediscovered? Or were they building upon knowledge passed down from cultures even older, cultures that leave only fragments behind? Maybe the most important lesson hidden in these technologies is that human curiosity has always been powerful enough to leap forward in ways that seem impossible. Every ancient device we study, every artifact that surprises us, every mechanism that bends the limits of our expectations, proves that human intelligence does not belong to one era. It belongs to every era. The people who lived thousands of years ago were not so different from us. They wanted to understand the world. They wanted to build tools that could solve problems, express creativity, and perhaps even push the boundaries of what was thought possible. And in many ways, they succeeded. As new discoveries continue to surface, in deserts, in shipwrecks, in old manuscripts, and buried beneath ancient cities, we may begin to realize that our modern view of the past is only a small piece of the story. There are still mysteries waiting to be uncovered. Still inventions waiting to be rediscovered. Still pieces of human brilliance scattered across the ancient world, quietly challenging us to rethink everything we thought we knew. And as long as we keep searching, the past will continue to reveal its secrets. Not to show us how far we've come, but to remind us that human innovation has always been far more extraordinary than we ever imagined.